So let's dig into creating common units, normalizing the data. A couple of items here. We're gonna just gonna maybe clean a portion of this up so that we can see what's happening. So I'll move things over a little bit. This is all just a formatting thing. Just make it look a little prettier for you. The idea of common units is instead of talking about the population as a whole, let me come down here. Let's talk about a portion of the population. Right now our study is all about male and female, right? So instead of looking at the population as a whole, can I look at male per population? Because really at this point, we're looking at, if we did this and multiplied by 100%, we would end up with a percentage of the population is whatever. So normalization has this real value because California is likely to have a percentage that can be compared to Oregon or really anywhere else, right? We can go all the way up to Wyoming, right? Let's look at normalizing this, and let's use our eraser. Well, I'm going to use my eraser. I'm going to clean this up. And let's insert a formula. If you're not real comfortable with formulas, just go ahead and copy along. You may want to become familiar, kind of do a Google search or something. But let's say male per pop. Just a little bit of foreshadowing here. There's some database violation rules taking place, especially in this field about week 5. We'll have a discussion about this. So if we do male per population, and remember when we say per is a, it's essentially like saying divided by, so it'd be male per population, right? So if we said equals, hey, we're going to do a formula here, male per population, and selected enter. Let's do a little formatting here. We know that this is approximately 51%. Let's go to our home tab and let's change it to percentage. And let's give it, let's just give it 1 decimal point and see how that plays out. There's lots of ways to copy this down. You could literally, I mean, you could actually just goes equals this divided by this and repeat that all the way through. That's just a lot. So we can select this green square and kind of hold, click and drag, and it'll carry everything over. Also, if you have an adjacent column, you can, instead of click and drag, you can double click and it will follow that column all the way down. Well, interestingly enough, we see numbers that are actually quite similar. They're within a reasonable range instead of a wild distribution of numbers. We have a fairly predictable or fairly tight distribution of them, something that's manageable. Let's run our statistics on this new column. So data, analysis, descriptive statistics. Okay, we're going to select a new column. I'm not real confident that there's nothing below there because we did some work. So I'm just going to click and drag. It is a column. There is a label in the first row. Output range. Let's put it down here so we can discuss it, on our own or separately. Maybe we'll reference back and forth. And there's our output range, and we want the summary statistics. So let's select OK. I'm going to put these in terms that are a little easier to manage. Format them by going to my Home tab, and we'll make them numbers. Let's put them down to say 2 decimal points, 2 decimals. Again, we have a sample size of 52, so n equals 52, which is good. We know that we didn't grab anything extra, right? Let's take a look at this, right? So this is our x bar, right? Our mean or our average, plus or minus 0.01, right? And kurtosis is 2.3. Ideally, this is 3, so we're much closer to what we should be. And skewness, we are definitely in the right range. 0 would be our ideal range. 0 to plus minus 0.5, and then is very symmetrical. 0.5 to 1 is moderately skewed. So we're kind of in the moderately skewed, but definitely a lot better than what we were dealing with before. Here's our minimum is 0.47, and our maximum is 0.52. This is nice because we don't need an excessive number of bins. All right, let's go ahead and set up our bins right now. There's no need to be tricky or coy about it. So let's do our bin range. And we'll start with our minimum, right, which is 0.47. And let's go 0.47, 0.48, 0.49, 0.50, 0.51, right? That way we'll end up with just a few columns to our bins. Let's go do a histogram and see how much this has changed. Data analysis, histogram. Our input range is now no longer the B column, it is now the E column. Again, just to make sure I didn't accidentally put something in the wrong place, I'm going to select, click and drag. We do have a label. Output range, we're gonna move that over here. And we want the chart output. Select OK. Uh-oh, something's gone wrong. Let's try that again. This is all going kind of screwy here. All right, hopefully yours turned out a little better. I'm going to redo this one. Sorry about that. chart is here. This is much better. Hopefully you got to this point a lot quicker than myself, and apologize about that. This looks much better as far as normal distribution, right? This is a very attractive bell curve, right? We're seeing this real nice, yeah, this real nice, and this is an advantageous situation because our statistics are more generally considered, or even strictly considered, normally distributed. And even more important is we have a way to compare California and Wyoming, right? Those are the big problems, right? So from a total population standpoint, right, we had Wyoming was 580,000 and California was 38 million. Well, now we can compare a component of it where 51% of Wyoming is males. California, only 49.7 are males. Let's look at some other items or some things that are already normalized. So we can look at it where we have something, a common unit, right? So common units are, in this case, would be, you know, excuse me on that, something per population, right? Where it's something per unit or something per larger that's common, whether it's population, especially for demographic, it's usually per population. But if we look at other things, we could say, we could compare averages, right? Right, we could compare averages as long as the averages were based on common units. Let's get rid of this. This typically is the most common one that we'll use for demographics. Just always look for a methodology that has this factor here. That's the common denominator, right? If you're not really sure if it's something that is normalized, ask yourself this question. Can we compare something like California to Wisconsin, or I'm sorry, Wyoming, right? Can those two be adequately compared? So percentages, this also represents a percentage, right? That's another one, because percentage usually has a denominator or a divisor. If you're not really sure about that, then you can feel free to email the instructor or ask a friend, hey, what do you think about this? But the critical thought is, okay, how do I compare California with Wyoming? Can I do that with this data set? All right, so moving forward, it is, when you get to your assignment for the week and all of that, very important that you consider normalization, because if the raw numbers cannot be properly compared, it's going to raise some eyebrows about credibility of the findings.